All right, so this is from Unit 2, Functions, and we're gonna, in Lesson 3, we're gonna look at characteristics of functions. Okay, we're gonna mainly look at graphs of the functions and then analyze the graph. So there are a few things we're gonna look at when we look at the graphs of a function. These are the 4 things we're gonna look at. The first thing is increasing and decreasing intervals. So when you're given a graph, you're going to look at where the graph is going up, increasing, and where the graph is going down. Sometimes the graph doesn't go up or down. We call it a constant. I mean, it's constant. It doesn't go up or down. And we need to be able to identify it. So a couple of things here. We always read the graph going from left to right. Okay, so we're going to start from negative infinity here and then go off to positive infinity on the x-axis. So left to right is on the x-axis. And another thing is we only look at the x-axis. We ignore all of the numbers on the y-axis. So we only look at here. So here are the official definitions for it. You can read those, but let's go ahead and try this example here. So we want to know where the graph is increasing, where the graph is decreasing, where the graph is constant, and we're going to use interval notation. Okay, so we're going to start from the left side. There's nothing here, but over here we see it starts at -5, and then until here. There's something going on here between -5 and then x equals 0. Well, the function is decreasing here. It's going down. So we say the function is decreasing from -5 until 0. Okay. When we're looking at increasing and decreasing intervals, we just always put open parentheses, because at this point it's not increasing or decreasing here at this point. Even though it's closed, for increasing and decreasing we always use open circles. Okay, and then at 0 it changes. This point where it changes, there's a couple of things we call them either turning points, where your function is turning from increasing to decreasing, or we call them critical points. Okay, all right, so here the function, it's now increasing. And again, it's going to be really hard to ignore the y-axis. Just remember, we're only looking at the x-axis here. So here, well, it's increasing from x equals 0 and then all the way up to here, which is at 2. And then from 2 until 6, it's constant. So from 2 until 6, we have a constant interval. So it's increasing from 0 to 2 on the x-axis. It's decreasing from -5 until 0 on the x-axis. And then it's constant from 2 until 6. Okay, so that's the first thing we're going to practice doing, is in increasing and decreasing intervals. The second thing we need to look at when we're looking at graphs of functions are maxima and minimum, maximum and minimum. So I think of maximum and minimum as hills and valleys. Hill is a maximum, valley is a minimum. Okay, so we look at a graph and we just go and mark where there's a hill, where there's a valley. You can have more than one of each. So a few things here. The difference between a local and an absolute. An absolute means the lowest point. Absolute minimum means the lowest point. This is a low point, but this point is lower than this point. So this is an absolute minimum. And this point right here is a local minimum, meaning that it is a minimum because it is a valley here, but it is not the lowest point. Same thing with this one. This is also minimum, but it is not the lowest point, so we call it a local minimum. And then a maximum here, this is a local maximum because this is a hill, it's a high point, but it is not the highest point. So we call this a local maximum, and then absolute maximum. This is the highest point on the graph. Sometimes you have them, sometimes you don't, so we just have to look at the graph and see. So here's an example. So what I do is I go in and I look at all of the turning points, the critical points right here, I mark them, and then the points right here we're going to check and see if they're minimum, maximum, local, absolute, all those things. So absolute maximum, so we have a max right here. I'm just going to write max, but it is not the highest point on here, because look, there's something higher here. So we can, and then actually since it keeps going higher, this does not have an absolute maximum because it just keeps going. We don't really say infinity or anything, we just say none. And then for absolute minimum, well, this is a low point, this is a minimum, but it is not the absolute, it is not the lowest point. There's something that goes lower. So there's actually, since it keeps going down, we say none. There's no absolute maximum or absolute minimum. Relative is another way to say local. Okay, so we say local or we say relative. There's an changeable relative. This is also relative, this is also relative. So relative minimum, sorry, relative maximum is right here. Relative maximum is right here. So we usually, when we're giving the value, we give it on the y-axis. So there's a relative maximum and value at y equals 6. So you can just write 6 here, or if you want, you can give that point right there. You can say there's a relative maximum at point 0, 6, and then the value is at 6. Okay, we give the y coordinate. Relative minimum, local, so it's right here. So it's at point x equals -6, and then y is at -1, 2, and 3. And then the value, the minimum value is at the y coordinate, which is -3. Still at 6. All right. And then increasing and decreasing. So this is going back to the previous lesson, so I'll just add it in here. So we want to, again, let's review. How do we know it's increasing and how do we know it's decreasing? We always start from the left. Okay, so on the left, your function is decreasing, right? It's decreasing, it's going down. And then there's a critical point here where the function changes. So it's decreasing from, it's not -10, it's actually from -infinity since it's going off the graph. So it's decreasing, I'm going to put it here, decreasing from -infinity until this point on the x-axis, which is at -6. And increasing and decreasing will always have open parentheses. And then your function changes, right? It changes directions from this point and it starts increasing over here until this critical point over here. So it's increasing from, again, on the x-axis, from -6, it changes there, until 0. And then it changes directions, and then it starts decreasing again. So it has 2 decreasing intervals right here. So to say that, we're going to add it here, and we use this symbol, okay? This symbol, I'll just write it up here, means union. In math, it just means and. Okay, it just means and. So it's decreasing from -infinity until -6, and from 0 until positive infinity. And you're like, well, it's going down. Yes, it is going down, but it's also going to the right on the x-axis. It's on the right side, it's going down. So we say it is going down from x equals 0 until all the way to positive infinity. All right, and then the next one, there is no graph, but we're going to go ahead and graph it on Desmos and then find all of the values. So let me bring up Desmos. All right, so let me go ahead and graph this. So I have f of x equals all of this. We can put f of x, or we can leave it out. It doesn't really matter. So negative 2x squared plus 12x minus 16. And then here's my graph. And then it's nice on Desmos because you can just click on the critical point. I have students clicking on all of these. We don't need these points. We just want the hill or the valley right here. So this is a hill right here. So on my graph, let me just kind of sketch it. It's at x equals 3, y equals 2. So this is my critical point. And then it goes down here. So there's my graph right there. So right here, it's at 3, 2. Okay, so here we want to check and see if if this point right here, is it an absolute? And it is an absolute maximum because it is the highest point on the graph. There's no other points higher than this. So this right here is an absolute maximum. So we can say at point 3, 2, and then the maximum value is at 2. Okay. Minimum, there is no absolute minimum because it keeps going down. So this is none. There is no relative maximum because there's only one max. So this none. Relative minimum, none, because there's no minimum point. Like there's no, what do you call it, a valley. So we leave it as that. All right, increasing and decreasing. So again, we start from the left, and then we say that on the x-axis, remember, if it's on the left side, we say negative infinity on the x-axis. So it's from negative infinity up until this critical point right here, it's going up, it's increasing. So from negative infinity until x equals 3, it's increasing. And then at this critical point right here, it changes and it starts decreasing. So it's decreasing from x equals 3 until positive infinity on the x-axis. Okay? So that's the second thing right there, and we're going to do a lot of practice. The third thing we need to be able to do is identify the x and y intercepts on a graph. Super easy. You just go through, and the x-intercepts are where they cross the x-axis right there. The y-intercept is where it crosses the y-axis. When we write intercepts, though, we do give it as a coordinate. So this coordinate right here, x is negative 2, and then y is at 0. Over here, x is positive 2, and then y is at 0. So on x-intercepts, y is always going to be 0. Vice versa with the y-intercept. On the y-intercept, my x is 0, and my y is at negative 1, 2, 3, 4. Usually on a function, you only have one y-intercept. You can have more than one x-intercepts, but on the y-intercept, there's only one. So again, on the x-intercepts, your y-coordinates are always 0. On the y-intercepts, the x-coordinates are always 0. So here's another graph here. So let me go ahead and mark all the intercepts. There's an intercept right there. Intercepts the axis. There's an intercept right there. So right here, the x-intercept is at negative 1, 2, and 3. And my y is always 0. There's another x-intercept here at 1. Y is always 0. Y-intercept, my x is always 0, and then y is at 1, 2, and 3, positive 3. Okay? And then another vocab word that goes with the intercepts are, or mainly x-intercepts, are the zeros and roots. So when you're asked to find a zero of a function, it's the same thing as an x-intercept, but it's just different how we write it. So for this function right here, we say, well, the zeros exist at x equals -2. We don't write it as a coordinate. We just give the point. The x-coordinate. There's an x-intercept at 1, and there's an x-intercept at 3. So same thing here. So we just mark it on here. We don't care about the y. When we're asking for a 0, we only look at the x-intercept. Only x-intercepts. Where does it cross the x-axis? So here, my zeros, and another word to say zeros are the roots, same thing, are equal to x equals -2 and x equals 3. Okay? All right. And then another way, when you're not given a graph, of course, when you're not given a graph, you're more than welcome to just graph it and see. But sometimes we ask you to check if these values are zeros of a function. To do that, what you do is you take each value, you plug it into your f of x, you plug it into your x's, and see if your answer comes out to be 0. If it comes out to be 0, then it's a 0 of a function. If it comes out to be a number, then it is not a 0 of a function. So on these ones, you would just check each one and see if it comes out to be 0. So for this one, when I plug in -1 into my function here, so it's -1 cubed plus -1 minus 3 -1 squared, so I'm just plugging -1's here, plus 3, does it give me 0? It sure does. So we can say yes. So all of this equals to 0, which means that x equals -1 is a 0 of a function, because when I plug it in, it gave me an output of 0. Same thing here. So over here, same thing. I'm just going to change all of the -1's to, we're checking if 2 is a 0. So let's check 2. I'm just going to quickly plug it in. 2. And again, once I plug 2 into the function, do I get a 0? No, I do not get a 0. I get a -15, which means that 2 is not a 0 of a function. Same thing with this one. Let me check if 3 is a 0. So let me just change all of these to 3, my input to 3, and see if I get a 0. No, I don't. Let me make sure I did all this right. Cubed. Nope. I get a -48. So this is also not a 0 of a function. Okay? And then the last thing I have here is end behavior. I think I'll go ahead and stop the video here, and then I'll do another video on end behavior. Okay, and then in that video I will do all these examples in here. Okay.